Alrighty guys, we're going to go ahead and get started with our electrostatic notes. And I've highlighted some important terms to know as I go through these notes today. Specifically, we want to know exactly what a charge, conductor, insulator, friction, contact, induction, grounding, and polarization all mean. So let's start off just talking about the basics of electrostatics. So electrostatics involve electric charges and the forces between them, and their behavior in certain materials. This is commonly known as static electricity, and you guys have experienced this before, whether it be rubbing your feet on the floor or on the carpet and collecting those charges and then shocking your friend, or when you touch a doorknob, getting shocked by a doorknob. All of you have experienced some sort of static electricity one time or another in your lives. So let's talk about electric charge and how it's the physical property which causes the forces between protons and electrons. This can be positive or negative. A negative charge is the result of excess electrons, meaning that when we have a negative charge, it's because we have a bunch of electrons. A positive charge is the result of lost electrons. Like charges are going to repel and opposite charges attract. And again, when we say positive charge, it's not because we've gained a lot of protons, it's because we've lost a lot of electrons. Electrons are the only ones that we are losing or gaining, meaning that a loss of electrons makes us positive and a gain of electrons makes us negative. So really quickly, here's an interaction chart between different types of charges and if they attract or repel. So two positives, well, we just said likes repel. Two negatives, likes repel. A positive and a negative, opposites attract. Positive and neutral, well, those are also still opposite, so those are going to attract. And a negative and neutral, again, still opposite, those are going to attract. Why don't charges typically result from gaining extra protons? Well, let's think back to chemistry. In chemistry, you should have learned that you have an atom, and inside that atom, there's electrons and protons, and on the outside, we have that electron cloud. And inside that cloud is where our electrons are stored. And close to the center is where our protons are stored. So on the outside, it's small, it's light, it's free moving. Those electrons can go wherever they want. On the inside, though, it's big and heavy and fixed in place, meaning that those protons aren't going to be able to leave. Therefore, electrons can move around easily, but protons cannot. A positive charge, like we said before, is a loss of electrons. The mass of an electron, something important to note while we're on this slide, is 9.11 times 10 to the negative 31st kilograms. And this is a number I'll give you because it's just a constant number. The mass of a proton is 1.67 times 10 to the negative 19th kilograms. Again, just showing that protons are a lot heavier than electrons. Let's talk about charges on objects. And we know that everything is made up of atoms, and those atoms contain protons and electrons. Therefore, on a larger scale, an entire object can receive net charges when the atoms which make them up gain or lose electrons. So let's think, why does your hair stick up when you rub it with a balloon? Well, here you are, right? Mean mugging right now. We got the balloon. Rub the balloon on our hair. What's happening though when we rub that balloon on our hair? Well, the balloon is actually taking electrons from our hair, meaning that our hair is now becoming positive. Since our hair is only positive, all those positive charges are going to repel each other and stick up like we're in some punk rock band from the 1970s. So insulators and conductors, what are they? Well, electrons are moved more easily in some materials than others. What do you mean electrons moving? What does that mean? Well, in very simple terms, moving electrons can also be viewed as electricity. So what types of materials easily allow electricity to move? Well, if we look at a conductor, inside a conductor, it's going to look something like this. where these negatives represent electrons, and they're all spaced out. Why are they spaced out? Because they're easily allowing our electrons to move. Just like we said, electrons in a conductor are able to move freely. Charge is evenly distributed. Some examples could be copper, iron, mercury. That's why all of our wires are made out of copper, because they easily allow those electrons to flow. Now let's take a look at an insulator. And an insulator might look something like this, where instead of these charges flowing easily throughout it, these charges are clumped together. In other words, these charges are stuck in a fixed place. Some examples of a good insulator could be rubber, glass, or wood. Think back to that first episode of Pokemon when Ash gets his Pikachu and his mom gives him those rubber gloves. Why does she do it? Well, that's because she doesn't want Ash to get shocked by Pikachu. And she knows that rubber is a good insulator, meaning that it will protect Ash from Pikachu's lightning, or in other words, Pikachu's buildup of electrons. Now let's take a look at some methods of charging. So one method of charging is friction. And before we dive into friction, we just need to understand that electrons are attracted more to some materials than others. And you guys notice this when maybe in the winter you take off your jacket and you hear kind of that static noise, how those electrons are being grabbed from your jacket and they're being ripped off of you. And then maybe you touch the doorknob like we mentioned before and you get shocked. Some materials collect charges easier than others. If we rub two objects together, electrons are able to hop from one to the other. This leaves the objects with opposite charges. So in this case, on the right, we have a balloon and like some piece of fur or something. And as we rub this balloon and fur together, the balloon gathers those electrons from the fur, making the balloon more and more negative. And since the fur is losing electrons, it's becoming more and more positive. The key takeaway is that friction leaves the objects with opposite charges. It is able to change the overall charge of those objects so that one is negative and the other is positive. Now let's take a look at contact. So we're going to define contact as saying that excess charges are able to move from one object to another just by touching. On the right-hand side, we can see that we have some object over here. Is it a conductor or insulator? Well, these charges are pretty evenly spaced out, so I'm going to say it's a conductor. So let's say that these objects over here on the right are originally neutral. So this sphere is neutral and this sphere is neutral. After touching it, we notice that electrons jump from the neutral object to the positive object because electrons are going to go to an area of less negativity, meaning that they're going to go to an area of the most positivity. As this neutral sphere loses electrons, it's going to become positive. Therefore, when I have this conductor and I bring it into contact with some overall positive object, the electrons are going to jump from the conductor to the positive object. And why are they doing that? Well, electrons are always going to go to the area of less negativity. So this positive is more positive than my conducting sphere. So the electrons are going to leave the sphere and hop over here.
And the rod is going to still maintain an overall positive charge, just less positive than before.
And then down here, we have a negative rod and a neutral sphere. A neutral sphere is more positive than a negative rod, meaning that the electrons are going to go from the negative rod over to the neutral sphere, now making the neutral sphere negative.
And the rod is going to still maintain an overall negative charge, just less negative than before.
Next one I want to talk about is grounding. And we're going to say grounding is really the removal of charge. So an object can become neutralized when you connect with a path to the ground. And the ground serves as an infinite reservoir of electrons. Positive objects take electrons from the ground to become neutral, and negative objects give electrons to the ground to become neutral. So again, grounding is just allowing us to make our object neutral. If our object needs electrons, the ground gives it electrons to become neutral. If the object has too many electrons, the ground takes those electrons away to make it neutral. Why are neutral objects attracted to charged objects? Well, very simply put, it's polarization. And polarization is the process of forced separation of charge within an overall neutral object. This can take place in conductors where electrons are free to move around easily. Something important to note, though, is that polarization is temporary. Since we aren't actually touching the object, we're not changing the overall charge of that object, and those electrons will eventually move back to normal. So down below on the left-hand side, we see that we have our sphere, and we have some positive and negative charges all moved around. Now we bring some negative rod towards it. What's going to happen? Well, we know that negative is attracted to positive. So the positive charges are going to move over here, and these electrons are going to move away from the negative rod. So now we're going to end up with something that looks like this, where on the left-hand side, we have positive charges, and on the right-hand side, we have negative charges, meaning that this object is still overall neutral. We have not changed the overall charge of it, but what we have changed is where these charges are. So if this object was big enough, the left-hand side of it we could consider to be positive, and the right-hand side would be negative. If we take this negative rod away, these charges will eventually mix up again and look just like we started. The key, again, with polarization is 1, that it's temporary, and 2, that it does not change the overall charge. Here's an illustration for some more detail, where when we bring that rod towards it, it pushes those electrons away, just like so. So here we go again. And by pushing those electrons away, making the right-hand side of our sphere more negative, but the overall charge of the object is still neutral because none of these charges have left our sphere. Why are neutral objects attracted to charged objects? Here's the diagram again for polarization, except this time with a positive charge being brought towards it. And we see that the electrons are now attracted to the positive charge, exactly what we would expect. So in this case, the negative charges move over to the left, and the positive charges move over to the right. And the overall charge of this object is still neutral. When I bring that positive charge over, those negative charges move to the left. Again, the object is still neutral because I have not taken any of those charges away. So let's take a look at this challenge question really quick. During a physics lab, you forgot which charge a certain object is. Luckily, you have 2 strips with known charges. One is positive and one is negative. How can you use them to determine the charge on the unknown object? If I don't know the charge of my object, first thing I'm going to do is bring my positively charged strip towards it and see what happens. If I bring the positively charged strip towards it and it attracts, that means I have 2 scenarios here. The unknown charge could either be negative because it's attracted to the positive strip, or it could be neutral because it's attracted to the positive strip. If it repels, then I know that it's positive because likes repel. So let's say that it doesn't repel and it attracts. Well, if it attracts, now I need to use my negative strip. And now I use the negative strip, one of 2 things are going to happen. It's either going to attract or repel. If the negative strip repels it now, it means that it was negative. If the negative strip attracts it, it means that it could be positive or it could be neutral. But we just found out that it was attracted to the positive strip, meaning that it can't be positive. Therefore, the only solution, if it's attracted to both strips, is that it is neutral.